factorial notation. So factorial notation we're going to use for permutations, but also we're going to see the limitations of our calculator on this and how we have to be able to understand what factorials are to be able to work with them. Now, 6 factorial, like I said, is just whatever that number is and everything less than it till 1. Okay? So, without using your calculator, 4 factorial would just be 4 times 3 times 2 times 1, which is what? 24. Now, how does your calculator do this? Your calculator does this by hitting the number 4, and you see a math button. Use the math button, and you're going to have to go 1 left or 4 right, whatever you want. It's cyclic, right? So if you go 1 left, you're in probability. Now you should see it down in 4. So you can scroll down there, you can just press 4, and there you go. That means 4 times 3 times 2 times 1. So hopefully that gives us 24. Now that's awesome. Okay? Now, if our calculator could do this, how is the diploma going to be able to ask us any questions? Because pretty well every one of the diploma questions, you can't use a calculator to get it. You can to check it, but not to get it. So here's a scenario. What if I gave you 800 factorial over 798 factorial? Okay, try that out. Now, just as we're doing this, what's the buttons I pick? Does anyone remember? Math, then go to probability, right? Then to number 4. Okay, what happens when you put 800 factorial divided by 7? What do you get? Overflow, okay? 800 times 799 times 798, that's a big number, okay? So here's how you can do this. See, 800 is the same, 800 factorial is the same thing as 800 times 799 times 798 factorial all over 798 factorial. So I can stop anywhere I want and just put the factorial because that covers everything. Now you can see what's happening. I can cancel 798 factorial with a 798 factorial. Don't get confused with a 798 and a 798 factorial. They're very different. But if they're both factorials, they can cross out. So now, all I have to put into my calculator is 800 times 799. Okay? So that's how my calculator can't help me. And you have to be able to understand the need for... So if we look at like B here, what's another way to write 5 factorial? Well, that's the same thing as 5 times 4 factorial. Or 5 times, 5 times 4 times 3 factorial. Okay? Obviously, 5 times 4 times 3 times 2 times 1 is one of the options. Okay? Now, how would I do this one here? 8 factorial over 5 factorial, 3 factorial. Okay? Now, first of all, always count down the biggest one until you see something that cancels. So 8 factorial will be the biggest one. So that'll be 8 factorial times 7. Oh, not 8 factorial, sorry. 8 times 7 times 6 times 5 factorial all over 5 factorial, 3 factorial. See, I counted that down. I don't have to go 5, 4, 3, 2, 1. I could, and then in the bottom, I could take 5 factorial and go 5 times 4 times 3 times 2 times 1. But then you're wasting time. Stop here, cross them out. And what is 3 factorial? 6. 8 times 7, 56. Okay? Now, if life was only that easy, the place we always have to go is the theoretical domain. I need this to work for everything. So we have to understand, do you know when I say 8 factorial, it goes 8 times 7 times 6 times 7. Do you see how we're always counting down? We're never counting up. Keep that straight. So do you know that n factorial, no matter what it is n times the next one less than that, times the next one less than that, times the 3 less than that, all the way to 1, where n is a whole number. Okay, that's been changed in your book. The other thing, 0 factorial is equal to 1. So if you look at these examples, n factorial is the same thing as n times n minus 1 factorial. Okay, and if you don't believe me, try that. Well, is 8 factorial the same thing as 8 times 7 factorial? Yeah. So this is just talking about that in a theoretical case. Okay? So let's go down to seeing how this works. Okay, so remember how we canceled on the last questions? Well, let's keep that same thing going here. But if I have n plus 2 factorial, what does that equal? What does this equal? What's the first thing that I write down? So 8 factorial would be 8 times 7 times 6. So what's the first number? N plus 2. So this is the same thing as n plus 2 times, what's the next one? N plus 1. Shouldn't it be always one less? Plus n. Why am I doing plus? Times n factorial all over n factorial. So that would equal n plus 2 times n plus 1. Okay? And again, use your creativity to think, how can I make that a numerical response? Now, it wouldn't be that simple, but they could have where there's maybe 4 of them, and they'll say add up a plus b plus c plus d. Okay, let's do 3. Yep. N is always in the whole numbers. Almost right with the other one. Okay, let's solve this one. N factorial over n minus 2 factorial equals 42. Okay, so let's take the biggest one and count it down till something cancels. Now, what's the bigger one? N. N is bigger than n minus 2. Okay, so let's try that. That would be n times, what's the next smaller one? N minus 1 times n minus 2 factorial all over n minus 2 factorial equals 42. These will cancel. That's n times n minus 1 equals 42. Okay. Then that's n squared minus n minus 42 equals 0. Okay. So two numbers that adds give me negative 1, multiply that would be n minus 7, n plus 6 equals 0. So n equals 7 or negative 6. It can only equal 7 though, right? Why? Has to be a whole number, right? Okay. Let's go to example 4 on the next page. Or sorry, Let's go right to permutations. Now, permutations. Order is important, okay? So, you know, it's important permutations, okay? Think of the P. Now, if I had, say, John had, someone said, there's the access code, 3, 5, and 7 are the numbers. I'm not going to tell you what order, though. Go. How many guesses would he take? How many possibilities does he have to try? In other words, what's the most he's going to try before he... Nine? Okay. Well, let's actually do it totally old school. Let's do them. Okay. Now that's not easy in itself, because how do you keep organized when you do these? So what I try to do is come up with a system. So maybe I'm going to start all the ones that start with 3. So 3, 5, 7. The other one would be 3, 7, 5. Those are definitely 2 different codes. Okay? Now, why don't I do the ones that start with 5? So I could have 5, 7, 3, or 5, 3, 7. Okay? I haven't done the 7s yet, so I could have 7, 5, 3, or 7, 3, 5. Okay. So there's 6. Okay? Now, there is 3 choices, correct? There's 3 things, 3 choices. That means that's 3 factorial, which is 3 times 2 times 1, which is 6. Okay? So in permutations, if there's 28 of you in here, and I had all the different ways that I could arrange 28 of you, it would be 28 factorial number of ways. Okay? In permutations, because order matters. So the way you sat in here would matter. You can see why we're doing factorial notation with permutations. Okay? So, permutations, you would use the exclamation mark, which is factorial notation, if I am arranging all of you. Where it gets to be different is I'm going to take all of you and I'm going to see how many different groups of 3 I can make. You cannot use the fact, well, you sort of can use factorial notation, but really we got to come up with another system. Okay, now let's talk about permutations. Now permutations are taking n different elements, n at a time. See, if I take 29 elements, 29 at a time, that's 29 factorial done. Okay? If I take 29 of you and I want to see how many different groups of 10 I could make, don't go 29 factorial. So we're going to learn how to be able to do it n at a time. Now, the notation is n, p, r. So it's n things picked r at a time. So if that was 20p3, I would say that's 20 things, pick 3s. Okay, so I use p, that's what I mean is pick. I know it doesn't mean that, but that's how I remember. 20, pick 3. You have 20 things, pick 3. How many different ways can I do that? That's perm notation. When there's a C there, that's combinations. I would say 20, choose 3. And 20, choose 3, there is a lot less numbers because order doesn't matter. Okay? So, the reason why we're saying that order matters here is for the perm reasoning. Now, if I just took, so just to reiterate, the number of permutations, if you take them, all of them, you just do n factorial. So how many ways can I rearrange all the letters in the word Regina, that would be 6 factorial, which is 720. Kelowna, count them. There's 7 different objects, that's 7 factorial, or 50, 40. Okay? Now, what if I am doing, like I said, I don't want to take all of them. So if I had the word graphite, now always know how many you have. There's 8 letters. It says how many different 3-letter arrangements can be made. Okay? So I have 8 letters. Now first of all, I am picking 3 of them. So this is how I would go. You can do it totally old school. Remember I told you yesterday with the fundamental counting principle? That's the first thing you learn. And sometimes we're like, I don't need that anymore. I'll do this. I find for perms, I do find the factorial or fundamental counting principle that work quite well. So if I have 3 spots, how many choices do I have for the very first one? I have 8. For the next, I would have 7 choices, and then I would have 6. And that's how you would solve it. Now remember, I always told you we'd have to go with the most efficient, easy way to do these. Many of these are a tie. But you know, if you can do them all 3 ways, and it takes you 2 minutes, that's cool. I would say that's a check mark saying, I got that one right. Okay? Now, you can also, in your calculator, just go 8p3. Okay? Now, by the way, this equals 336. Now, how do you do this in your calculator? Quite simply, have to go 8, hit your math button, go over, see where it says NPR. So you go 8, and you can hit enter or 2, whatever, 8p3. That means I have 8 objects. I am picking 3 of them. How many ways can I do that? I can do that 336 ways. Now, which one was faster? It'd probably be a tie, 2 people raised. The 8 times 7 times 6 makes sense, though. Or the 9p3 or 8p3 or whatever, I think you're going to get an answer and just go, yeah, I guess that's good. That's what my calculator gave me, right? Okay, there's also a formula. And the formula is on your formula sheet. And you can do this without your calculator. And I'll show you how. So using this formula, remember we were doing 8p3? Well, that would be 8 factorial over 8 minus 3 factorial. That is 8 factorial over 5 factorial, right? Remember I told you always count down the bigger one. That's 8 times 7 times 6 times 5 factorial over 5 factorial. Gone. That's 8 times 7 times 6. And we already know that is 336. Okay? There is 3 ways to do the same question. Okay, let's go over here. Just, again, 0 factorial is defined as a value of 1. If you ever forget that, there is a way to figure it out. Use your calculator. Okay, it'll do it. Now, let's do some questions. In a region, we have license plates that first consist of 2 different letters followed by 4 different digits. So how many blanks? 6. 1, 2, 3, 4, 5, 6. Okay? We're going back to fundamental counting principle. Now, the first 2, these are letters, right? But not every letter. These, no. Okay? So how many choices for the first blank? 22. Second blank? 21. Okay? Now, these are 4 different digits. Are we allowed to repeat? No. It's very specific about them being different. So the first one would be 10 times 9 times 8 times 7. How can I write that in perm form? Well, let's just talk about the letters. How many letters to choose from? 22. I am picking a group of 2. So it would be 22p2 times 10p4. Now, once again, I stress that if you use the fundamental counting principle, it'll get you through just about every single perm question. But that doesn't mean you have to not know how to use the formulas and not how to use the calculator. But when we get to the harder ones, the really, really, really hard ones, the fundamental counting principle is the best. Okay? So that's, to me, that's the one that students understand. The other one, this little black box gives them, they're like, yeah, okay, sounds good to me. Okay, it's even on the multiple choice. I love it. Okay? So let's get this question done. Solve the equation n minus 1 p2 equals 90. Now, I'll be honest, if it was me, I'd guess and test that n. Probably take me about 30 seconds. Okay? Because the first one I put in, if it was way too high, I'd just go a bit lower. You know, I would. I could beat anybody doing this one any other way. And you could too. So don't fall into sometimes, I know we all do it. You're like, it's math, it's complicated, it's a diploma, it's worth a lot of marks, I better make this thing as complicated as possible. Don't, okay? Try and see. So I'd guess and test this one. But I'm going to show you how to do it without guess and test. I'm going to use the formula. The formula is n factorial over n minus r factorial. Now in this case, what is n? It's n minus 1. So that's weird right away. So we're going to keep that straight in our head. So it'll be n minus 1 factorial all over n minus 1 minus 2 factorial. Okay? So that's the same thing as n minus 1 factorial all over n minus 3 factorial. Okay? The negative 1 minus 2. Which one's bigger? N minus 1 or n minus 3? Good. So if it's bigger, chop it down. This would be the same thing as n minus 1. Right? Always name it first. Times n minus 2 times n minus 3 factorial all over n minus 3 factorial. These cross out. Remember, this equals 90. So I have n minus 1 times n minus 2 equals 90. If I use FOIL, that is n, oops, I don't need brackets, n squared minus 3n. Oh yeah, that's supposed to be a 2. What am I doing with a 9 there? That's why I'm all confused. Okay, minus 3n plus 2 equals 90. Get everything to the left, and I will get n squared minus 3n minus 88 equals 0. Okay, two things that add to give me negative 3 multiplier give me negative 88. negative 11 and 8. So n minus 11, n plus 8 equals 0. So n equals 11 or negative 8. We already know negative 8 is bad. Therefore, here would be the question. I know it would be. What is the size of the group? What's the size of the group? 10 or 11? It's the number in front of P, correct? What is the number in front of P? 11 minus 1, which is 10. So n equals 11. But remember, we're confusing it with the real n, so we would say the group size is 10. The multiple choice, I have seen this one on the diploma, and people pick 11. Okay? But if you look at it, if you substitute it in, it's always the number in front of the P, right? 8P3 means 8 people, pick 3 of them. And how many ways can you do that? Okay? That's what we're doing here. Okay, so we're doing 1 to 11. And then, oh yeah, just ACE and 12 to 15. Now, I do want to show you how you can. Now, this is a skill that many of you would have to acquire if you want to get 100 on the, but your calculator can solve this one for you. So in Y1, put the left n, I put it in brackets actually, x minus 1. Go to math, P 2. And in Y2, put in 90. If you hit graph, zoom 6, you should see nothing. Right. So all you have to now do, go hit second graph and get to your table. Because I put Y2 as 90, it'll always come up. But what you want to do is, if X is 11, Y1 turns into 90. So you didn't really need to do a Y2, actually. You could just look at when it's going to equal 90. Okay, so there's, I'm sure that on the diploma they're not expecting people to use their graphing function on this, but it does work. Okay, and guessing and testing doesn't take that long. You put in 6, P2, it's way too small. So you try 7. Maybe you're going to go up to 9 right away. It's still not enough, right? Maybe you're going to go by 2s. Then you went over it. Go back 1. I'll tell you, you're looking at 30 seconds of guessing and testing on that one even. But what they're going to get you on is you're still going to get it quick. You're going to get the right n, but that's not the group size. Okay? If it was n minus 2 up there, you got to make sure you take n and minus 2 before you answer that question. Okay? It's a tricky one. I've got some practice diplomas that we're going to be writing, and one of those is on there, and it gets a lot of people. Okay? So okay, so you got about 5 minutes. You still can get quite a few done. These go very quick. Okay? And it is something that you will find quite confusing. Luckily, you have a solution manual.